2A asks us, what if you had 5 degrees of freedom? And then let me read how it says. It doesn't actually say alpha. It says it has probability of 5% to the right of T star, or that is the critical value. So that is the area of the right tail. I have to be careful in calling this alpha, that we're not talking about a two-tailed test where alpha equals the two tails added together. This is just all the alpha in the right tail, so to speak. Okay, so we find 5%, and we find 5 degrees of freedom, and there's your answer, 2 point, if I can see, 015. Letter B asks us to find, well, what about 21 degrees of freedom? By the way, that would be a sample size of 22. And then it has a probability of 99% to the left of T. Well, 99% to the left of T is just the complement of what? That would be 1%. So this is B. So they're being tricky here. Here's our critical value. They're saying we got 99% here. Well, 99% is not in this green oval here. The highest we get is 25%. So we're talking about 1% to the right of the critical value. 1% is right here. Our 21 degrees of freedom is way at the bottom here, and this is 2.518. So that's how you find a critical value, or a t-score, from Table C. Now I'd like you to try number 3 on your own, and let me show you. Let's see, I said I was going to do what? Number 9, and then you can give 7 and 8 a try. Let's take a look at number 11. Oh, what have I done here? It's 11.9. 11.9. Okay. I can get this right. And we are talking about vitamin C content in a low-cost fortified food that's pre-cooked. Sounds tasty. So, for whatever reason, here's our data, and they could only take a sample of 8. Perhaps it's expensive to do this kind of testing. And this is where, we don't have a sample of over 30, so we cannot use the normal assumptions, and we cannot use our z-score. And we're supposed to, letter A asks us, and this is on 628, you probably need to look at the question for this to make any sense. What conditions must be satisfied in order to make inferences about mu? Well, we need to know that it doesn't come from at least a strange, highly skewed population. This sample is really not going to tell us too much. It's only 8 points. But what can you say about it? There's a couple on the left, a couple on the right, and 4 in the middle. So, if you grouped them a little bit more in a histogram, you might see something like this. It's by no means normal, but that's the best we can do. I actually have the answer from the answer key saying that it is difficult to check normality. A stem plot shows that there are no outliers. So I guess that's what we're doing. Even though these guys are down here, they're down here together, and they're not too far from the mean. And by the way, I did put these in my calculator, and the mean is right here. So we do kind of have a high center with these 3 gathered here at the mean of 22.5. So that sample is not normal shaped, but it could come from a normal population. And sometimes when we see something ambiguous like that, we say, well, we're going to hope for the best, and go ahead and try our t-statistic anyway. The next part is construct a confidence interval for mu, and then C is to do the hypothesis test. I think for the sake of time, I'm going to skip over B and go ahead and do the hypothesis. And also the hypothesis is so outrageously high, I'm going to just make my own. And let's say that the null hypothesis is that we have to meet a standard, and that standard is 30 milligrams per 100 grams of food. So that is that the population mean of this is, in fact, 30. Well, our mean is 22.5, but we do have some data points over here. We have a 26 and we have a couple 31s. So who knows? Maybe that's accurate. And then, without having taken the sample, we're just wondering if we meet the standards. So then the alternative, and sometimes I put a 1 there, but I'll put an A for alternative, is just that it does not equal. A warning to you, I think one of your problems is number 8. There's some kind of typographical problem where this chapter, and it was also in the answer key, does not have, you'll see this. You'll see up arrow. And unless that's some symbol I don't understand, I think that's a crazy mistake, and it's supposed to say not equals. So beware of that on number 8 when you do the assignment. What's our next step? Let's name our tails. Well, here we are going to do a two-tailed test, and there are a couple things we need to be careful about. One is when we look it up on table C, that we are recognizing that we're looking up an area here, and then that's going to be doubled. And then when we do the p-value, we'll have to keep that in mind, that we don't just have p on the right, but we'll have a little bit of probability area on the left, and we'll need to double the p-value we get here. So let's take a look at this. Okay, so I've written down the formula for the t-score, and I also got this off my calculator. I forgot that they're not going to give us sigma nowadays. We have to come up with our own. And those 8 values gave us 7.2, and then we plug these guys in. So I've plugged those values in, and I've gotten myself a t-value of negative 2.94. And now we are not quite sure how fat these tails are. I mean, that's a huge z-score way off to the left. But let me just draw it in here, negative 294. Now you'll notice this, of course, is on the left. We need to know the area of this tail, but it'll be the same. This is a two-tailed test, and so we'll have 294 over here, and we'll just take this p-value and multiply it by 2. But wait, there aren't very many probability values on the table, so let's take a look at that. Okay, so here we are on table C, and I've got the 7 degrees of freedom highlighted. And now we're just going along looking for that critical value. These are not percentages. Obviously, it goes over 100%. We're looking for that 2.94, and we get to here. This is too high. This is, so we're right in between here. In between what two values? 1% and 2%. So that's best we can do with a table. We can say that P is between 1% and 2%. But wait, remember that we're talking about this being 1 to 2% and this being 1 to 2%. So really we have a broader estimate that the p-value is somewhere such that we add those two together, it's between 2% and 4%. That still beats a 5% significance, doesn't it? So the null hypothesis would be rejected. And our alternative was just not equal, but we see that we're a little bit on the low side. So that's what these low numbers, especially, these guys ruined this requirement that it was supposed to be 30, and it turns out this food does not have enough vitamin C. Okay, good luck on the problems, and remember, if you have a two-tailed test, you'll need to multiply the p-values by 2.